Hello students, welcome back. Now let us study trigonometric functions. First, some limits of trigonometric functions, and here are a couple of important formulae. This one is extremely important. The second one is not as important, but still remember this. Why these are true? That goes pretty deep, and we'll do that in a separate video. Next, derivatives of sine and cosine. Derivative of sine is cosine, derivative of cosine is negative sine. This too gets pretty deep, so we're going to come back and do this in a separate video. How about other trig functions? Derivative of tangent is secant squared, derivative of secant is secant times tangent. Derivative of cotangent is negative cosecant squared. Derivative of cosecant is negative cosecant cotangent. The second line and first line are very similar except for the negative sign. These four formulae are not difficult, but they are tedious. Again, we're going to do them in separate videos. For now, let's focus upon how to use them, and let's begin with the limit problems. So let's talk about problems that we have to utilize this one, and especially this one. Okay, let's begin. How about the first problem? How do we handle that? It's quite obvious that we have to use the first formula because we have sine functions. This one is about cosine. We have sine functions. How do we manipulate so that we have theta and then the same theta down there? Well, we have x squared and then we have 7x there. So if this had been 7x and then 5x, we could apply this formula, but there's a problem. These two are no longer the same. Here I have x squared. This is originally where we started. Here I have 7 and 5 multiplied. So in order to make it fair, we need 35 multiplied into this numerator. So basically what I did was multiply 35 to both numerator and denominator so that we get this. 35 times limit x is going to 0, sine of 7x over 7x, and then times sine of 5x over 5x. What's this limit? 35. That was there before, so this 35 times, what's this limit? It's 1. And how about this limit? It's 1. So this whole thing is equal to 35. Basically, we are squeezing the problem so that it fits into this. Let's check the answer. Yep. Oh, this is good. I color coded even. Sine of 7x over 7x, that's blue. Sine of 5x over 5x, that's red. Okay, next problem. X is going to 0, x cotangent of x. How can you apply either this or that? Did I say this one is extremely important? This one is important too, but not as much. Again, it's going to be this problem. Somehow re-express cotangent so that you can use this formula with respect to sine. How do you do that? Cotangent is equivalent to cosine over sine. So this whole thing is equivalent to x cosine of x over sine of x, and then what's happening to x over sine of x. Look at this. The red part is going to 1. So this is 1 times cosine of 0 cosine of 0 is 1. How about the next problem? Does it still look like some problem with respect to this? Well, yes, it is. One of the things you have to think about when you have some polynomial in limit problem is to factor it. If you do that, you'll see something like this: x minus 1, x plus 3. And then sine of x minus 1 over x minus 1 behaves this way. Sine of theta over theta, where theta is going to 0. You see, x is going to 1, so x minus 1 is going to 0. So what do you have? We have 1 times plug in x equals to 1 plus 3. So this is equivalent to 1/4. You see, to this one, you can just plug in x equals to 1 because that doesn't go to 0. The red part is 0 over 0, but that'll turn out to be 1. What's the answer here? Yes, it is 1/4. Enough time for another. Let me see. I'll leave the last problem to the students. Let's move on to the next example set. How do you calculate the derivative of these? Excuse me, change of plan. Let's go back to limits, and then let's do this, and then let's take this derivative problem in a separate video. Okay, how about this problem? Does it have anything to do with either this or that? Well, let's see. Before that, please note that this is again 0 over 0 type limit. X is going to pi over 4, is sine of pi over 4, cosine of pi over 4, that's both square root of 2 over 2, so denominator is 0. Tangent of pi over 4 is 1, so this is 1 minus 1. Yes, this is 0 over 0 type limit, which means we need some work. We're going to use either this or that, so we have to have some sine of cosine. So let's rewrite this tangent as sine over cosine. Hard to see, so let me expand the font. Okay, and let's simplify. One way to simplify is to multiply both numerator and denominator by cosine of x, the denominator of this, to simplify. So let's go ahead and do that. Multiply cosine of x to each term, we get that. and then multiply cosine of x here, we get that. Do you see a simplification? You get 1 over cosine of x. As a matter of fact, no. Negative, because this is cosine minus sine, this is sine minus cosine. So this is negative 1 over 2 over square root of 2. Oh no, let's write it as 1 over square root of 2. So this is negative square root of 2. I didn't use any of those. But still, I think this is correct answer. Let's see, it is true. And turns out, yes, this is a very method I used in my answer key. And I'm a little bit surprised that the last problem didn't have anything to do with this or that. Or maybe it had something to do with it, but I just found out an alternative method. In any case, it works.